Alrighty, in the interest of time, then let me send the slide deck to Mark, and then he will continue from where we left last time. Mark, you should have got the controls now.
Yep, and I think everybody should be seeing my screen. Can everyone see this?
Yes, I can. You need to put the yeah.
So we left off last session talking about barcodes, and we'll do a brief review on the barcode section, just kind of summary recap, if you will. So essentially, barcodes act like license plates. Let me try to shrink the controls. Of course, sorry. Trying to shrink the controls of GoToMeeting, and it has terminated. There we go. Barcodes essentially act like a license plate. What a license plate is to a vehicle, barcodes are to assets, goods, and anything that's going to participate in a barcode-oriented system. It's a series of numbers that, if decoded, have meaning on an open supply chain market, and also can be used internally without said decoding. Typically, there's a number of different types of barcodes. We cover a few of them here. These are some of the more widely used symbologies. And there are more complex barcodes. So 1D barcodes are kind of the mainstay of that market. 2D barcodes are becoming more prevalent with the advent of better optics in devices. Frankly, your cell phones read 2D barcodes and can bring up associated web pages and all sorts of extra data that can be embedded within them. And if decoded properly, the actual data can be stored in the barcode rather than having to refer to an external database. Again, number of different types we look at here. Someone's microphone is open and we're hearing a lot of chatting. Can everyone mute their microphones, please? Is that just my end, or are you hearing that as well, Sanjeev?
Yeah, I think I'm hearing the static, and there are. If everyone can just mute their web, microphone, that will be great.
Let's see here. It should show me. Don't see.
I can mute everyone.
Yeah.
And then
muted.
Okay. Yep, went away. Excellent, thank you. Let me get back to my. Come on. Back up. Okay, here we go. And so again, with the advent of cell phones and better optics on devices, we're able to start utilizing these in different locations. I've seen these in everything ranging from retail stores to museum tours. Of course, all sorts of conferences and those sorts of things where rather than having people there to give you information or expensive equipment, they can print a barcode and embed this data in there. The challenge with this, again, line of sight and one at a time. These are they're great for specific things, but there are much better alternative for other types of applications. And again, comparing barcode to RFID, right? Barcodes cost a fraction of a cent because you can print them, and it's the cost of the paper and the toner, as opposed to RFID, which is going to be a higher cost because now you're attaching a circuit to whatever it is you're tracking. However, the benefits are vastly different. It's going to be much harder to replicate or to impersonate, if that's an intent, and it can uniquely identify items where with a barcode that takes a much more complex system to be able to do. wireless non-line of sight, batch processing. I mean, we can read these things at 1200 a second. It's fairly significant difference on the speed of which this can impact supply chain systems and many other systems as well. And if anyone has any questions, just unmute your microphone and ask your questions, and then please mute again so we don't have interference. So I think we were just starting to get to readers when we last left this session off. And here you'll see some common types of readers from manufacturers we all know and work with. Excuse me, there's a couple of variations here on fixed or mobile readers. We'll talk about these. The readers themselves they perform a few functions as it relates to the tags. They provide power to the tags, so they generate a baseband power for, well, and again, this is as it applies to passive RFID. They communicate over a network of some sort, and this can be a serial network, this can be an Ethernet network, but this can be wireless. I mean, there's a number of options, and in fact, now they can be Bluetooth or many other forms of communication. They will generally support multi-protocol reading. For the purposes of this training, we're primarily focused with, again, I think I've mentioned this, UHF technology, and in that we have EPC and ISO and GS1, and those standards are built into the stack, the communication stack that these readers operate within. They have the ability to run external devices and can communicate with ladder logic devices or dry contact devices such as lights, horns, electric eyes, ultrasonic sensors, all kinds of things. And the form factors are varied. We'll cover up a little bit more on that here in a few slides, but the primary form factors, as it says here, fixed and handheld. There's some that I'm looking at as I see ultra mobile readers. They're getting smaller and faster and cheaper, which is kind of standard rule of manufacturing, right? As these things become more and more of a commodity type object, manufacturing has been wonderful to this industry as we've gone from building readers to actually manufacturing them. We'll talk more about that, but and generally they will have more than one antenna port, but not all the time. I've seen readers that are the size of a business card with the antenna built right in, and just excellent things in our future with this. So again, here's a few different reader types that we'll see. The handheld and mobile fixed. The single protocol or multi-protocol, basically, if your tags speak a language, your readers have to support that language. Otherwise, you're not going to be communicating with the tags. That's just how that works. And so multi-protocol readers are very cool as we look at specific applications, because if you're in, for instance, a distribution center and you're getting tags from everybody, you want a multi-protocol reader that can identify that tag and speak its language natively, and that gets you the most efficient communication. Readers can be either bistatic or monostatic. Now, multi-static is a new thing they've coined the phrase on. Monostatic basically uses a single antenna to transmit and receive, where bistatic uses dedicated channels. We talked about the possibility for an integrated antenna. External antennas, in handhelds, for instance, you'll have a reader module with a single antenna port, or in printers, RFID enabled printers. Generally, there's going to be a small RFID reader module with a single antenna port, because that's all it needs. However, in larger applications, if you think about dock doors or forklifts, or any place where you might have a larger read area, you're going to have the capability to hook up 2 to up to 32 antennas if you employ the use of a hub for the antennas. Readers can be powered in a number of ways, but the bottom line is they have to be powered. So PoE is becoming more prevalent, which is power over Ethernet. This is a global standard by which desk phones have been powered for quite some time now. And the dumb or smart readers, I don't know if there's anything dumb about a reader, but some of them are there just to perform the function of reading. That's all they do. Others have the capability to run programs right on the reader. So you can write programs or install them directly to the reader, and it has an onboard computer that will run those in addition to reading the tags and performing communications, doing all the other things it does. So as far as standards compliance goes, there's the air interface, and that's basically the communication between the tag and the reader. And then there's the host interface, and this is the reader to the network, and thus the legacy systems behind that. From a global perspective, again, looking at a supply chain type application, having the ability to read any tag and being frequency agile, so I can have the same readers here that I have installed in my facilities in other countries, increases the availability and uptime of my overall application and supply chain, decreases the demands on my support team, right? Because if we learn a single model reader, that's all we have to support, and that's all we'll know it well, and we'll be able to troubleshoot it regardless of the region that's calling for support. And many of the global readers have software-defined radios. These were a great addition to the hardware of RFID technology. I'm going to say probably 10 years ago now, but field programmable gate arrays is the technical term for these. Essentially meaning that as new standards develop, a simple load of software on the reader can change how that air interface, as well as the host interface, communicates. And so they make them essentially future-proof to a certain extent. The things that they can change in software will change. The things that cannot change, obviously there's going to be a need to upgrade readers eventually, but with the field programmable gate arrays being now common, that becomes less and less of a regular occurrence. So as new technology emerges, right, just load a patch on the reader, and now you support the newest protocols, which is great. As far as network support goes, this varies, again, depending on the type of the reader, but some of the common protocols are listed here. At a very high level, Ethernet, wireless Ethernet, Bluetooth, these are some of the common standards you're going to find for network support. Many of them also support communication over serial networks for specific to manufacturing environments. If you think about the older networks that are still in use in many manufacturing facilities, RS-232 and RS-422 networks, those sorts of things. We talked about the embedded code, so the reader can perform other things besides just reading the tags. So now readers have the capability to push a little bit of edge processing and lower the traffic going across the network. So you can essentially assimilate all of the reads into a report and now send that across the network rather than sending each individual read. That makes a very big difference on the health and capacity of the networks they operate on. Most will support some sort of SNMP device health monitoring. We'll talk about middleware, I guess, later on, but there's something to be said for this particular aspect of the readers. In the past, the software that interfaced with readers was designed just to get data, right? Because they built on legacy barcode platforms where all you had to do was read what was being pointed at. Now these devices are smarter and capable of much more. And if they're managed properly, they can be very powerful. If they're just left to their own devices, they can be a nightmare. A reader turned on full power all the time in a building with 20 other readers turned on full power all the time can be very problematic. So having software to manage these is very important to ensure that you don't run into problems like that. We'd mentioned the host interface support. Let's take a look at what else we've got here. So as we look at fixed readers, UHF, and again, some of the standard suspects are here in the picture. Obviously, Motorola is now Zebra. Alien's still out there, and CSL and Impinj and Intermac. There's a bunch of players in this game. This talks a little bit about what we covered earlier. So this is a high-level schematic, if you will, of a reader's internal construction. But it's an example of a monostatic reader in which one antenna does both transmission and receipt of data. So it uses a high-speed switching mechanism that toggles the antenna back and forth between transmit and receive very, very fast. This reduces the overall complexity of installations, and seems to be the way the market has gone. These are great designs for most applications. In a bistatic configuration, you've got one antenna dedicated for transmit, one antenna dedicated for receive. So just to make sure everybody's had their coffee and is awake, can anybody give me an example of where I might want to use a bistatic reader? No takers? Man, we got to get some more coffee for you guys. So I'll give you the answer. A bistatic reader, personally, I've used them in situations where you need to absolutely ensure that you're going to get a read in very challenging read situations. So bistatic readers are more sensitive because they do have that dedicated listening channel. So a lot of times where you may have a questionable read circumstance, you're going to want a bistatic reader. And sometimes it's a matter of speed or difficult scenarios where you might have long distance range where maybe you just absolutely have to ensure that read. So yeah, truth be told, there's not a lot of bistatic applications out there these days because the electronics as this market has matured have gotten better and better, and the monostatic readers perform very, very well. The bistatic reader gives an added expense. So normally the readers that are going to support bistatic or multistatic tend to cost a little more because of the added circuitry and complexity they represent. Again, looking at some of the standard suspects here, if you will, within the industry. Let's see, Impinj, Intermac, Zebra, ThingMagic, Alien, CSL. These are all great readers. I've deployed every one of them on this screen. I don't know if we're going to look at model-specific information, but a little bit of history on these. Alien was one of the first monostatic devices on the market. They've done well with their readers. Impinj came out a few years later with initially just selling designs for readers, which was the idea being to help them propagate their reader chips and their tag chips. CSL to the left there initially was the sole producer of readers based on Impinj's schematics and designs. Impinj has since started selling readers and doing very well at it. Frankly, they've got great technology. Zebra was the Motorola readers, and Motorola Solutions, Enterprise Solutions, sold to Zebra a few years back, and they've done really well. This reader in particular is a multi-static device. So this one offers both bistatic or monostatic in under the same device, whereas these top three are all monostatic. The Thing Magic is monostatic. I believe Intermec offers both modes, so bimodality there. And Sanjeev just pointed out to me that you're all muted, so no one was able to answer my question. I apologize. I believe you can unmute yourself if you have questions, so please do that if there are questions. And I should be checking in the comments. I suppose I could do that now. Oh, okay. So here is the Zebra FX 9500, and again, we talked about this one. This was a this is a very powerful reader, actually. This one, this is the bistatic capability of this has led me to use it in a few implementations where other readers were not quite as sensitive or were not quite as fast. But again, that line is getting closer and closer as the technology matures. The monostatic readers have come very close in performance to what bistatic readers are capable of. So it's a fairly rare occurrence where the additional dollars for both the cost of the reader as well as the support and infrastructure are going to be justified. But there are cases where you're going to want that.
So I got a question for the readers.
Yes.
Do they, you have LF, you have UHF, all of the different spectrums. Do the readers, are they specific to a spectrum, or is that through the antenna?
That's a great question. And yes, the readers are generally specific to a single frequency or a frequency band. If you find a reader that says it supports multiple frequency bands, such as an HF and a UHF reader, that's actually two readers built into the same box. So I've seen one example of that in the past where there was a pharmaceutical authentication sort of application, and manufacturer had come out with a multi-band reader, and it was really two readers operating off the same power supply and communication backbone, which is great. But ultimately, at the end of the day, it's actually two readers built into a single box.
Was that one configurable for the different ports? Or was like port 1 and 2 for one type and port 3 and 4 for another?
That's correct. It was dedicated ports for the various bands. I don't believe that reader's made any longer. I haven't seen it in quite a while. Initially, it was slated for again, pharmaceutical application where ensuring the authenticity of drugs was critical, right? So it was a fairly niche market, and I think ultimately in the end they settled on two different readers because, I mean, right, if one fails, now you're replacing the whole box rather than just one reader, right? So it became a fairly expensive proposition to support. Does that answer your question?
Yes, it does. Thank you.
Great, thank you. Reader selection generally is going to be based on your use case, this application testing and verification. I mean, frankly, a lot of times the reader selection is also based on your client's existing relationships. So, I mean, you walk into a client site and they're an Intermec shop. The last thing you want to do is force them into another brand when they already have relationships with a given vendor and already have a help desk trained to support said vendor's hardware. It becomes a much easier sale, as well as a longer term relationship, sticking with their existing infrastructure if they're happy with it. So a couple of things to consider there. But that said, there are the Impinj Speedway is a great example. Impinj offers technology that other readers don't. So they're a very technologically advanced reader. But again, you got to kind of set the bar at good enough, right? So if reader A performs all the functions I need, but reader B has all this extra stuff in it, Well, look at the price differences, look at the support relationship, look at, there's a number of things basically that come into this calculation. If you're going to take advantage of some of those technologically advanced features, then sure, it's a great reason to make the pitch. If the customer has just an application that's going to be fairly simple, fairly straightforward, maybe that's not worth all that investment in time to convince them to move from vendor A to vendor B, for instance. We're vendor neutral, so I mean, frankly, a lot of reader vendors, and in my experience, reader vendors get the leads for deals, and then we'll bring them to folks like yourselves that, hey, there's this customer looking for this. Well, obviously, you're going to dance with the one that brung you, right? So there's pros and cons to every reader. Getting to know them as you deploy them and as you work with them does have its benefits, because as customers look to you for recommendations, knowing the ins and outs of these can be very helpful. And there's plenty of information about all of them on the web. That's why I love the internet for that. You can check obviously with the manufacturer's site, and you'll find all sorts of good stuff there. You'll also find chat rooms where people talk about their actual experiences with the readers, and that might yield yet some more information that could be of value. So. This again dives into the FX9500 specifically. This operates in the UHF band and is capable of operations worldwide. So it supports the bands from 860 to 960 megahertz in UHF. This has 8 ports and they're configurable. So these can be 8 monostatic ports or 4 bistatic ports, because on bistatic, you're gonna have a dedicated transmit and a dedicated receive to accommodate a single port, if you will. It's actually 2 ports, but acting as one because you're dedicating those channels. You have the GPIO configuration. This is where you would attach things like motion sensors, light brakes, ultrasonic sensors, things that do presence detection. So if you want to start a read based on something entering your read zone, GPIO is where you go for that. As well, it handles output devices. So being able to turn on a green light when the zone is active, and a red light if something goes wrong, or sounding an alarm if you're in an outdoor environment. Maybe you're not going to be able to see a light, but you'll hear a horn, things of that nature. This supports Ethernet, obviously. USB connections. Generally, these aren't used for reader communications for tag events. These are normally there for other things. I believe on this specific reader, they were capable of tag communication events going out through the USB port, but that's a fairly rare function in my experience. RS-232 on the serial port. This again is built in just in case you're deploying into a manufacturing environment, or on a vehicle where you may not have Ethernet, and maybe that's just a serial network that's there. So this shows a kind of a typical connection design. So a high level connection, right? We're connected to all of our antennas, and this is either 8 monostatic antennas, or 4 pairs of antennas in the dedicated transmit receive model. An Ethernet connection going back to the network where the customer data needs to get to, and potentially USB to a computer for loading updates. Again, this particular reader, I believe, can handle communications just as a Ethernet via USB, but it's much more rare for something of that nature. And then the power supply, obviously connecting this thing to the wall. This needs 24 volts DC, so you don't necessarily have to connect this to AC power. 110 volts if you're in the States, or depending on what region of the world you're in, that's going to vary. But you can connect this directly to DC power if you have it available. Low voltage power is kind of preferred in certain environments because it doesn't require as much of a regulatory overhead. Things like, for instance, the conduit and the licensed electricians to install it and that sort of thing. If you're in also on vehicles, you won't find the presence of AC. Generally, you have to use DC, or you have to put an inverter of some sort in to make that jump to AC, only to flip it back to DC again through the power supply that you buy with the reader. So many times it's just better to stage that power to DC, the appropriate 24 volts DC going into the reader and connect it directly. Ensuring, yes.
For the power, does any of them support power over Ethernet?
Many do. I do not believe that this one did due to its power requirements. But yeah, most of the readers on the market today do.
And just to jump in, this is just obsolete model. It has gone end of life, and the new one, FX9600, has been announced by Zebra, which do support PoE.
Yes.
Okay.
Yes.
Thank you.
It's important to ensure that the ESD precautions here at the bottom, it's no joke. You want to make sure the readers are grounded wherever you install them. An ungrounded circuit can be hazardous to the electronics and to people. So handling electronics, handle this just like any other computer or related object. I say that with a word of caution though, because I've seen how some people treat their laptops. Be cautious with these. They're expensive, and you don't want to hurt it by not treating it properly. So use all the standard precautions to avoid static discharge directly into the reader. So this gives a kind of a breakdown of the GPIO port specifically. These optically isolated ports, anybody who's deployed into a manufacturing environment, these are kind of industry standard and always recommended if you're hooking up to other systems. Using opto-isolated ports can prevent you from having to replace very expensive electronics. These have the capability to use digital inputs or communications from other complex systems, or just dry contact as well. So where things like a light break may just have a wire connect or a wire disconnect on a signal, they support both those types of communications, as do the outputs. So here's some of the current handheld models you'll find on the market. These are great for exception processing. So generally, when things go right, you're going to have a fixed area where your reads are going to occur, and generally a fixed reader is going to be attached there to automate just collecting the data as things move. Now, that's not always the case, but most applications. Handheld readers are great when something goes wrong and you've got an exception. You generally want to quarantine an object in an area of its own and handle that exception. And so handhelds are great because they're mobile. You can take it with the object, determine the status of the object, and send it on its way relatively quickly, and using an application that interfaces the network in the same way that fixed readers do. But now it's portable, and you can put that power in someone's hand. It's also great for things where you may not have fixed infrastructure, right? So if you're, I think back to some of the applications I've deployed. I mean, there's agriculture is a great one, right? You're out in the middle of a field. What are you possibly going to attach a fixed reader to? Having a handheld reader there is great. In manufacturing environments, it's nice to have a handheld reader because you can use them to locate objects which might have been otherwise lost, and save time. Example here being the MC9190Z and the 3190Z. These at their core had the same reader module, different designs. One's designed for rugged environments, one's designed more for nice carpeted retail environments, or indoor use where it's not going to be quite as ruggedized. So this gives kind of a high level of what you'll find with the reader, right? There's a keypad, and these keypads vary. You can order them with full-on QWERTY keyboards, on board. You can also get them just with the 10 key variant if it's just numbers you're concerned with. You know, they're fully configurable for things like Bluetooth, things like Wi-Fi. I believe they support all of the latest security standards as it applies to Wi-Fi networks, as well as communications. So, you know, ABGN, all the standard suspects there. These are great too because they're not just reading the tag. You can act on the data right there on the screen because you have a fully functional computer in your hand. So it gives the users a little more ability as it applies to manipulating what happens with the object in question. So for any reader, handheld or fixed, to communicate with a tag, it must have an antenna. The readers provide the power and the intelligence. The antennas act as a conduit to deliver that to the tags. Antennas come in lots of different shapes and sizes, all for specific purposes, and as well some for general purpose. So I mean, these guys here, for instance, these two in the top left, are what's referred to in the industry as general purpose antennas. They range from 8 inches square to, I've seen them up to 14 inches square, generally about 1.5 inches or 2 inches thick. The most common connector you're going to find on them is a reverse TNC connector, which has kind of become the industry standard due to really ruggedization. I mean, some of the antennas used to come with just UHF ports on them. The UHF ports rather were SMA, and it's a much smaller connector. And to tighten a connector on those took 8 inch-pounds of force, and so they would break frequently. And so the industry has moved largely to the reverse TNC connectors, which take a lot more abuse before they break. But there are other sorts of antennas. I mean, this impinged antenna here, for instance, is used for one of the common uses for it is race timing. So it's made to be trampled and stepped on, and it actually does have that SMA connector I referred to earlier as being kind of fragile. But these won't just be laying on the ground, right? They're going to be in something on the ground. People will step on them then. So they do require a bit of care in that regard. And there's full-on floor mat antennas. So I mean, I'm not this particular model I've not seen before, but it looks very similar to one I've deployed. It rolls out. It's an entryway carpet, and you hook 2 wires to it, and now you have antennas that can tell you if people have RFID tags on them or objects, what's going in and out that door via this floor-based antenna, which is kind of a neat concept. The ×7 antenna in the upper right corner. This is similar to these general purpose antennas, but very, very thin. So these can get down to, I want to say the last one I saw from them was about 3/8 of an inch thick. So for space constrained environments, they're excellent. So these transmit the reader's signal, that baseband power that lights up the tag. And then these also look for the anomalies in the field, which are the tags responding back, right? We talked last session about tags affecting resistance across their own antenna to signal the reader back. Well, these are what receives those signals and give that back to the reader. As a general rule, when frequency increases, the wavelength of the physical wave communicating to the tags decreases, and antenna size can decrease. That can be a little deceptive though, because you'll see large antennas occasionally that are designed for higher frequencies. Generally, that's a function of range. Antenna size will a lot of times determine its range. But again, that can be deceptive too, because LF antennas tend to be fairly big, but they only have, up to 1 meter of range. So it's kind of something to consider there as well. They can be circular or linear polarized. Circular gives you the ability to read a tag in any orientation in front of that antenna, where linear, the tags are, if they're not oriented properly, tag reads can be missed because the tag just will not receive enough power. We'll talk a little more about that. Here's some examples of some of those readers or the antennas we were talking about. The antenna, okay, so the antennas on a tag we talked about during tag construction last session. Those are the tag antenna. These are just referred to as antennas, but these are really the reader antennas. The patch antenna design is kind of the most common. It's a simple design, not very complex, but very effective, and generally has a good front to back ratio. We'll talk about what that means here in a minute. You'll also see monopole antennas, dipole antennas, loop antennas, slots, beams, Yagis. For the most part, what we'll be dealing with are patch antennas. You will see the occasional application where some of these others are used, and understanding their construction can be important. But they're generally going to be fairly application specific. We'll talk more about that as these slides continue. Looking specifically at UHF antennas, this is the patch antenna. This would be the cord connecting to the reader, the physical connection back. Generally coaxial cord, always coaxial cord actually. We'll talk about that more in a minute as well. Behind every antenna, you're going to have some sort of a ground plane. This is what keeps the antenna signal going toward the front of the antenna. Without it, that antenna has the ability to now radiate in all directions. And so this is a concept called gain, and we'll talk more about that, I believe, in a slide or two here. The antenna parameters we're concerned with: directionality, directivity, the radiation pattern, gain, polarization, and tag orientation. And we'll talk about these as our slides progress here. So antenna directivity. Has anyone heard this term, there's no free lunch? No, everybody's mic is muted. I keep forgetting that. Sorry. So you put power into these antennas, they cannot possibly transmit any more power than you're giving them. But we need to boost that power to communicate with tags many times. So we do that by focusing all of that power in a given direction. And this is called gain. So if you think about a garden hose, right? And the water coming out of a garden hose comes out at a fixed rate. You're not really going to increase that. Once the faucet's open, the faucet's open. But if you wanted to get more pressure out of that garden hose, you can put your thumb over the end of it and restrict it to just a narrow little beam of water coming out of there, narrow channel. And now you get this high pressure, right, that you can use to help wash difficult stuff off your car, mud, whatever, right? Antennas do very much that same thing, particularly in UHF. So all of the power that we're putting into that antenna, we want to come out the front of the antenna. So we will focus that beam generally down to about between 70 and 80 degrees off the face of the antenna. So that the gain of that is put into what's called a polar map, which we see here. And this is how we would measure the power of that antenna. Generally, you're going to have distance marks on this polar map, and it'll show you how far away from the face of the antenna, which would be here at the center, your tag reads can occur. And we measure the power out at the edge of that field, which gives us the width of that antenna beam and the length of that antenna beam, right? So we can utilize this to help select what antenna is going to be right for our applications. Sometimes you want a very narrow beam that's being pushed way far forward. Other times you want what's seen here, which is more of a bulbous beam, and it doesn't go as far out, but it covers a wider area. And so, I mean, you can think of this like a balloon, right? The more you squish that balloon side to side, the longer it gets, right? You let it go and it kind of comes back to round. Well, similar concept here when we're focusing RF power. And this, again, is kind of a breakdown of what that polar plot would look like. And the gain is measured in dB, decibels, and I believe we cover that on the next slide, or slide or two. So in concept, this is what we want our antenna fields to look like. They never do, due to impurities in the metal, impurities in the solder used to connect the joints, and just all sorts of different reasons. Your antenna lobe will end up looking a lot like this, and there's going to be spots in there where you're going to have weaker coverage and stronger coverage, and they're just not overly consistent when it comes to down to just specific power across a given area. So understanding that is very helpful to designing your applications to not miss reads. There's a front to back ratio. So as you focus that beam from the antenna here, right? The idea being we want all the power to go to the right of that, which would be the face of the antenna. Some of that power is going to be transmitted, it's the wrong word, but pushed behind the antenna. And so there's something we call a front to back ratio. Having that ratio more front is going to be better, obviously, towards your application. But knowing this back lobe exists is also beneficial in your application design. So if, for instance, your customer wants to read stuff here, it's important to let them know not to stack things here behind the antenna, because sometimes you're going to read those things unintentionally. Now, if you've got intelligent reader management software and you can overcome that, to overcome those blind spots is really a matter of, and I think we're going to show a picture of this here in a minute, multiple antennas get that done, right? Because no two antennas are going to have the exact same pattern. They're going to have differences in where those weak spots and stronger spots are in the field. So if you have overlapping coverage, generally that's the way to fix that. Now, that said, a single antenna can also get it done, because the hole is not going to be a channel through the beam that has completely no coverage. It's going to be spots across that beam. So if I have an antenna casting a 6 foot wide beam in my intended read zone, I might have a couple of spots in there where I don't have coverage, but across that 6 feet, I'm going to have the ability to read that tag, right? But that said, it's always good to have redundancy, right? So more than one antenna focused on that zone is going to generate a better result. Full stop. So forward gain is what we're looking for, and again, this is expressed in dB. A dB is a relational, decibel is a relational measurement. There's no finite definition of a dB. It's referenced against an original unit of measure. We'll come back to that one. So, but the higher the gain, essentially, the more, just like with that garden hose, right? The more pressure we want out of the garden hose, the smaller we're going to make the beam of water coming out of the garden hose. Well, same stuff with RF. The higher the gain, the more power we want to push into our intended read zone, the narrower we're going to make that beam. We're going to focus that beam. So a very narrow beam will deliver high power across a further range than a wider beam. That'll be kind of the softer flow of water, right? So the higher that dB, the more power you're going to deliver in the intended read zone, but the narrower that read zone becomes, because you're focusing that antenna beam. So where one antenna might have that 6 foot wide beam in your read zone, if you get a higher dB antenna, that narrows that beam, and you might only have a foot or two wide beam that's trying to reach a further distance. So these are things to consider when you're designing your read zone. Shown here, right? This is a low gain antenna. Here's our antenna, and the face would be looking to the right. This is the kind of, again, if we're comparing this to the garden hose, this is the wide open garden hose. Just nice wide beam, fairly consistent coverage range, where this one is focused, and we've put our thumb over the end of it, and we're trying to get the dirt off the car, right? It's pushing that water harder and faster and further, and that's what a high gain antenna would do. Now, if your objects are traveling down, as relative to this drawing, if we're going down the page, going through here, we've got a pretty wide area to read that tag in. Here, we've narrowed our read zone considerably, but it's higher power and thus more sensitive. And so there's trade-offs to be considered. And you may have a wider area to cover. So for instance, if this is 8 feet, well, we might have a 16-foot area we need to cover. So we're going to want a higher gain antenna to go across that. But there's an alternative, and I know you guys are all muted, so I can't ask the question. But if I wanted to cover a wider area, and I wanted this wide read zone, but I have a wider area to cover, what do I do? Well, the answer is to put another antenna here on this side facing in. And so now we get double the coverage, right? More infrastructure costs to do it, but we're going to ensure our intended reads. And generally you want those antenna zones to overlap. So here in the middle, the other lobe coming from the right would probably end here. And we'd have another lobe just like that. So this depicts what a linear polarized antenna would look like. The beam coming off of that antenna, right, the wavelength, is going to, this puts it into visible form, is going to be flat and focused on a plane, in this case horizontally. That means the tags, to read optimally, sometimes to read at all, are going to have to be horizontal and thus parallel to that antenna. These are great when you want to read things. For instance, if I'm on a manufacturing line and I've got objects that are coming off of a machine and they're always in the same orientation and they're always stacked the exact same way, this is great, right? Because I can deliver all of the power on a single plane and I'm going to increase my chances of reading those tags. However, if I've got stuff stacked and it could be any orientation, well, this is going to be hazardous because I might miss that read. Right, so here we show what can happen if the tag does not align itself. You might miss that read. So with a circular antenna, it's actually splitting the power of that reader onto 2 planes, so a horizontal and a vertical. And now, as a result, that tag can be oriented any way it really wants to, as it applies to that antenna. Let me go back to that slide for a second. So the challenge, circular antennas are great because, sorry, I got a message here. Circular antennas are great because it doesn't matter what the orientation of the tag is. You're going to stand a real good chance of reading that tag regardless of how the object enters the read zone. However, you sacrifice range for this orientation insensitivity. So a linear antenna is going to have more power delivered because it's only on, for instance, in the case of this last slide, a horizontal plane, where a circular antenna is now splitting that power horizontally and vertically. So it's not quite a half, but it's going to significantly reduce the range of the antenna and the power delivered to the tag. Again, most applications, linear antennas aren't going to be something you have to worry about for the most part. There are specific applications where you do. I've used linear antennas as part of a location system where I didn't want to read a tag in the wrong orientation. So we intentionally blinded ourselves to those tags by having linear antennas that would only read in a specific orientation. In other cases, again, thinking of like a dock door or doorways pretty much of any kind, you really want a circular antenna because you never know how an object's going to go through that door. So really this kind of dives into RF theory a little bit, but as the distance between that tag and the antenna increases, that energy available to power the tag decreases. So for far field, which is again that UHF technology or the bulk of the UHF technology, it's by the square of that distance that power decreases. And I think of this, we refer to this as power density. Reality is if I've got a spectrum analyzer, I can still hear that reader even at a range that a tag's not going to be able to communicate because it's very sensitive, right? A spectrum analyzer is very sensitive and is going to see that. The tags aren't that sensitive. So they need to be in a very dense area where they can collect the power they need to communicate. And so these are considerations for when you're designing your read zones. But again, thinking about that garden hose, right? If I wanted to, if I attach that garden hose to a sprinkler and I want to get something wet quickly, I'm going to put it right next to that sprinkler and it's going to get the bulk of the water all over it, right? But it's a sprinkler, so the water's going everywhere, but because I'm close to it, I'm getting most of the water on whatever that is. If I put that object further away from that sprinkler, the density of the water, it spreads out, right? So now I'm getting less water on my object and more water on the area around it. Same exact concept with RF power. If I'm closer to that antenna, that power is much more dense, much more compacted, and delivering to that object. As I get further away, there's less and less of that power. Hopefully that makes sense. But you have to have a certain amount of power on the tag for the tag to even function. It has to be able to turn on the integrated circuit attached to the tag chip, attached to the tag antenna, as we talked about in our tag module last week. So we talked about the antenna and tag orientation. The maximum read distance is when both are parallel to each other, as seen here. If you have a linear polarized antenna and they don't match, in this case we have a vertical, the antenna is turned, so the wave is vertical, but the tag is horizontal. You're not going to read the tag at any kind of distance that way. They will read as you get closer. They generally will collect enough power that way in real world operations. But to be ideal and to not miss your read, you want those oriented properly. Okay, and so this does talk about you don't want the tag, even with a circular antenna, to be essentially end on or on edge as it applies to the antenna. It's very difficult if you're traveling across a 6 foot wide beam, for instance, to keep that tag with the edge facing directly toward the antenna. So the reality is tags will generally read as they go through there in any orientation because you can't maintain a perfect edge as you pass a fixed object unless you're turning that tag as it goes by, right? So at some point you're going to get the opportunity to read the tag. However, you're going to get the best chance of a read if the tag is parallel to that antenna, not edge on. This is the edge on concept. Now, if I'm doing that edge on, again, as I'm traveling past this antenna, there's only one specific point where I will be truly edge on. But I'm not going to collect power very well when I'm edge on, even as I'm traveling past there. I will have degrees of separation, but there will be one spot specifically in front of that antenna where that tag is not going to read. However, it will read, just not nearly as well as it should as you go through that zone. So this is the best orientation, right? Having the tags oriented such that they're facing that antenna in one way or another on a circular antenna will ensure that you get maximum read results. How are we doing on time? The challenge with PowerPoint is it hides my clock. And actually, I think we're getting pretty close to the end of our session here. So I'm not sure. So yeah, just a quick note on this one. Your testing, when you're testing for applications you might deploy at your customer, it's important to consider the real world characteristics of your customer's site. Testing in a lab is great. It's going to ensure that your application is going to run smoothly and you've got all the kinks worked out. But testing in a lab is only in a lab. You want to test against real world conditions. So if your customer has things that are going to potentially interfere, you need to know about them and emulate those conditions in your lab or test in that environment. So I mean, that's a couple of things to consider when you're talking about RF labs.
And
so
we are going to have this lab while we are there in Orlando.
Oh, great. So we've covered, and Sanjeev, if you could unmute everyone's mics, that would be awesome. We've
Unmuted.
Here we go. It was a master mute and it muted me. So
yeah, sorry.
No worries.
Unmuted all. Yeah.
We've covered all these topics across the last 2 weeks as we've gone through this module. Does anyone have any questions? Oh, great. Well, I appreciate your time today and look forward to seeing you all in Orlando.
And just a note, again, Fast Track RFID certification training is going to be in room S320, F&G. Exam slots are on subsequent days, April 11th and 12th. From 12 to 2, it is advisable to book your or reserve your spot so that you have the choice of the spot. And the next review webinar is next Monday, March 26th at 10 a.m. ET or 7 a.m. Pacific Standard Time.
Are the exams being held in the same spot as the training?
Typically, no, but I'm going to find out. I had already requested for the room allocation for exam slot, that which room we are going to be in. I'll let you know probably by next Monday which room the exams will be held. All right. If no further question, we look forward to see you on Monday. And as usual, if you have any questions in between, please shoot a mail to us, Sanjeev, myself, Sanjeev, Archit, Jean, and Mark. We are here to support you in any way for the training as well as for the exam. So thanks a lot and have a good rest of the day.
All right. Thank you, gentlemen.